And welcome. Today, we're going to pull back the curtain on something we all use, probably without a second thought: the simple electric fan. I mean, we use them to cool down all the time, but have you ever actually stopped to think about the incredible science that makes those blades start spinning? Well, let's get into it.
Seriously, think about it. It kind of feels like magic, right? You flip a switch, you press a button, and suddenly there's a breeze. But it's not magic at all. It's actually a super fascinating chain of events that's all powered by physics. And today, we're going to walk through exactly how that happens.
So, where does our story begin? Well, it all starts with the very first step in the fan's journey: electricity. It kicks off with that simple flick of a switch and a flow of totally invisible energy. And that's it. Step one. The second you complete that circuit, electricity starts zipping from the outlet in your wall right through the cord and into the fan itself. It's basically the fuel for everything that's about to happen. Okay, now we get to the really cool part: the absolute heart of the whole operation, the electric motor. This little powerhouse is where the real transformation begins. So, the whole job of a motor is actually beautifully simple. It takes that electrical energy we just fed it and it turns it into physical movement, into spinning. But how on earth does it do that? This is where the magic really happens. It breaks down into three key steps. First, that electricity flows into these really tightly wound coils of wire. Second, and this is a fundamental rule of physics, that moving electricity creates a magnetic field. All of a sudden, you've got these invisible magnetic forces swirling around inside the motor. And third, those forces start to push and pull on the inner part of the motor, which is called the rotor, forcing it to spin around and around. That's the big moment. Electricity becomes magnetism, and that magnetism becomes motion. So we have motion. The motor is spinning like crazy. But a spinning motor by itself doesn't really create a breeze. For that, we've got to transfer that spinning motion to the blades. So let's see how that connection is made. And yeah, it's pretty much as simple as it sounds. That rotor, the part that's spinning because of the magnetism, is physically attached right to the fan's blades. So as the rotor turns, the blades have absolutely no choice but to turn right along with it. It's just a simple, direct connection. But here is a really key detail. The blades aren't just flat paddles whacking the air. No, their specific shape, their angle, is engineered to act almost like tiny airplane wings. As they spin, they don't just stir the air around. They're designed to slice into it and actively push it in one direction, right at you. That directed movement of air is what we feel as that cool, refreshing breeze. So clever. Okay, so we know how the fan starts up and we know how it makes a breeze. But what about when we want it to go faster or slower? The different settings? Well, that's where the regulator comes into play. You see, the secret to controlling the speed isn't about the blades or the motor's mechanics. It actually goes all the way back to the beginning of the process: the amount of electricity. That speed dial on your fan? It's basically a gatekeeper, deciding how much electrical current gets through. And the relationship here is incredibly direct. When you set the fan to a low speed, the regulator only lets a small amount of current reach the motor. Less current means a weaker magnetic field, which, you guessed it, means a slower spin. But when you crank it up to high, that regulator opens the floodgates, sending a ton of current, creating a way more powerful magnetic field and making those blades spin much, much faster. So let's do a quick recap of that whole journey. You flip the switch, which sends electricity to the motor. That current creates a magnetic field. The magnetic field makes the rotor spin. The spinning rotor turns the blades. And finally, those specially designed blades push the air forward, creating the breeze we feel. From a simple switch to a cool room, all in a fraction of a second. And that brings us to a final thought. This amazing principle, turning electricity into motion using magnets, it's not just in your fan. It is hiding all over your home. So, what other devices can you think of that rely on this exact same bit of physics? It's a really cool question to think about the next time you hear the whir of an appliance starting up. Thanks for joining me today.